And welcome everybody to Subnet Saturday. It's 11 a.m. Pacific time here on the Pacific time zone. And it is so good to have you here. If you're just joining us, for Pete's sake, welcome aboard. Great to have you. And what we're doing is we're continuing a journey together through the world of CCNA, and also on Saturdays, we're allocating it just to subnetting, IPv4 subnetting, one of the coolest topics ever. Also, one of the most important things to be aware of and understand how to do if you're going to be working with computer networks, especially when it comes to troubleshooting. So our objectives, we're going to talk about Vlsm, the objectives of why it is and why we need it. I'll give you some concrete examples. And then we're going to leverage some of the tools that we've been learning up to this point and actually do an example with Vlsm. And as we do that, you'll see two things. One, okay, I get why it's required. And two, based on all these previous videos in this Subnet Saturday collection, I can do it. And that's our goal for today, is to understand why and also be able to do it in measurable terms. Also, after we cover Vlsm, I'll stick around as usual and we'll do some Q&A. If you have any questions regarding CCNA related or specifically Vlsm or IP addressing, bring them, save those for me if you want to see them till the end. Also, I'm looking at the queue here. There's a bunch of really great people in this room right now willing to help and answer questions. And so to everybody, the moderators, thank you very much. And also those people who are just helping out other people and answering questions. I'm so glad everybody's here. Some of us are here to learn and some of us are here to teach. And one of the secrets is when you teach other people what you know, it helps reinforce that in your own mind, and it's a win-win, which is my philosophy in life these days. If it can be a win-win, it's a good thing. So let's do this. Let's imagine that you and I have been put in charge of a branch office. And let me bring up a topology in the branch office would look something like this. So here in this branch office, as I move my mic over so I can still be heard, I've been told, rumor has it, that it's good to be heard occasionally. So at this branch office, and we could have, let me bring out this pen. Maybe we have a corporate office over here. Here's corporate. And they've got the corporate headquarters, and then they're connected via some type of network connectivity over to us. And this is our branch. And what they've told us is this. Hey, you, Keith and you, if you would do me a favor and make all of these IP addresses in your network at this branch office fit and be within this address space of 10.67.83.0 with the 24-bit mask. So we might ask the question because we're curious, right? We're always curious. Hey, what's going on at the corporate office there? What kind of addressing schemes are you using there? And how about other branch offices? And are you doing summarization? And all those questions will be answered as you and I continue Subnet Saturday. So for this discussion, we're just going to focus our attention on this branch office right here. And we've been asked by corporate to make the addresses space here in that IP address space of 10.67.83. So here's what we might do. We might say, great, we can do this. Let's first of all identify how many networks we need. Now, if you're new to the Subnet Saturdays, there's also a collection, a playlist that I put on my YouTube channel that makes it easy to find it and just go through them in order. It's important to not try multiplication and division, generally speaking, if you don't understand addition and subtraction first. So that's where we are on this point. So you can enjoy the video if you're brand new. Glad you're here. And I also encourage you to go back and backfill. So when you get to this point the second time, you say, oh, I get it, block size. Oh, I get it, finger game, because we're going to use all those techniques. So starting off, we'll identify our networks. There used to be a sign I used to work at Paramount Pictures back in like 93, 94, and I managed a team of technicians. But the programming department there, they had a sign on the wall that said, you start coding, writing the software, and I'll go see what they want. And it's a joke because we should find out what is needed first before we start, creating something. Like which building do we put the ladder on before we start climbing? So let's imagine we have a few networks and we say, well, in this network topology here at the branch office, we've got several networks. Let's just label them. This is A, hanging off of gig 00, and network B, we'll call that B, this network between R1 and R2. And I've drew in a few switches, but just imagine that off every routed interface, there's a switch or two, and there's devices that are all connected. And then right here between R2 and R4, it's a directly connected network, but that is a network, so we need a network address there, C. So far, what we're doing is we're identifying how many subnets we need to create. We've been given one major network. We need to go ahead and figure out, okay, how many subnets are we trying to create? So far we have 3, A, B, and C, and then we have this link between R1 and R3. That would be D, And between R3 and R4, that'd be E. And over here, gig 00 off of R4, which should be F. Let's see, A, B, C, D, E, F. Let's imagine, for purposes of discussion, that we need to create 6 subnets. And so we're like, okay, a little reminder here. Let me go to the big screen. A little reminder. If we have a mask of 24 bits, that's what's given to us. That's our starting point. And we need to create 6 new subnets. How do we're going to grow the mask. The mask, which is 24 bits now, is going to be something longer, because whenever we're doing custom subnetting, we're making the mask longer, which means we're taking away from host bits, and we're using that additional length to help carve out individual subnets. Sort of like a huge Elm Street, and instead of using just one street name like Elm Street, we're going to carve up into smaller streets like Elm Court, Elm Way, Elm Lane, and so forth. And so when we do that with custom subnetting, we are going to make the mask longer. Now the question is, how much longer do we need to make the mask? It's a 24-bit mask now. We need 6 new subnets. How many additional bits above and beyond the above what we're given, the 24, do we need? So we think it's a quantity question. And here's what I remember Keith and us talking about in previous sessions, is that whenever there's a question of quantity, how many bits, we're going to do this. Put your thumb up, and on the back of your thumb, there's a number. And I want you to think about what that number is. If you've been with me through these previous 2 or 3 sessions for Subnet Saturday, you know that on the back of that thumb, that digit there is a 2. So our fingers represent bits. We start with 2, and then we simply go to the number we need. Now we need 6 new subnets, and the question is, how many bits do we need to get there? So you put your thumb up in the air and you say 2. Not enough. We need 6. You put another digit in the air, and you see double that, 4. Still not enough. You put another digit in the air, 8. Oh, that works. We can have 8 new subnets by just stealing 3 additional bits and making the mask 3 bits longer. So that's a little bit of review from what we've covered before. So our mask, which was /24, is now going to be a /24, 25, 26, 27. So our mask is going to be a /27. So let's pick up that game, and let's take it to our topology, and let's do it. So here in our topology, if the mask was 24 and now it's going to be a /27, let's carve out those subnets. So A, B, C, D, E, F. That's our 6 subnets. Okay, so far, so good. So our first subnet, and this is an easy part of starting this, is that the first subnet with the longer mask looks like the parent network, meaning Keith, the network we're given is 10.67.83.0 with the 24-bit mask. And what that means to us is that the first network is going to be 10.67.83.0. It looks identical, except for the mask, which is going to be 3 bits longer, which is a /27. So there's our first subnet. And my question for you is, how do we know what subnet B is? So if you want to chat that in, that would be awesome. But like the first subnet's easy. We identified the mask. It's the /27, 3 bits longer, because that'll give us 8 possible subnets, 2, 4, 8. That's still true. But what's the next subnet going to be? There was a really cool, it wasn't a circle technique. It wasn't a rectangle technique. What was that? And if you're saying, Keith, we're going to take the block size, and you just add the freaking block size, and that's the next subnet. So as you recall, the block size is the last bit that's on in the mask. So up here, I'll use a slightly different color. If this is the 3rd octet, and thanks for the feedback in the chats, by the way. If this is the 3rd octet, and now we're dealing with the 4th octet, if it's a 27-bit mask, it would look like this. I'd have 24 bits on all the way up to this point, and then 25, 26, 27. No high math here. And then there's the dividing line, and everything over here would be host bits available for host addressing, says the mask. As I put too many zeros in there. All right, 0, 0. Oh, no, that's 5 zeros. Yeah, so I think, there we go. So our mask would be like that. So it'd be 24 bits from the first 3 octets and 3 from the last octet be on the mask. And then our block size is 32. And it's yeah, nailed it. You guys are rocking. It's 32 is the block size. And so what we're going to do is take that block size and say, well, the next subnet's going to be 10, 67, 83, just using little markings to indicate the first 3 octets are never going to change here. But the last octet is going to be 32. And that's going to be /27 also. Great. And then what's the next subnet going to be? And you might be thinking, well, Keith, you mentioned earlier in a previous Subnet Saturday session that we're just going to keep adding the block size. Just add the block size, add the block size, add the block size for each of your subnets. That's true. So for network C, it would be 10, 67, 83 dot, and then add the block size, which hasn't changed, still 32. So 32 plus 32 is 64. And it doesn't matter what level of math skills you have or don't have. If you ever have a question, you can always just do it manually. If the current subnet is 32 and you want to verify what that is twice, just add them up, 4 and then 6. Great, 64. It just doesn't matter if you want to do it longhand just to verify. After you've worked with IP addresses for a few years or a few months even, you might have some of that memorized, but just do the long math if you need to. All right, so that's subnet 64, and then subnet D would be this, and then add the block size. So 64 plus 32 more is 6, 9, and that'd be 96. We're doing great. And then the next one would be plus 32 more, which would be 8, and 9 plus 3 is 12, so 128. So that would be 128. And then for our last subnet, it would be plus 32 more, which is going to be 8 plus 2 is 0. Well, 8 plus 2 is 10. Hang in there with me. Carry the 1, and then this would be 6, and then it'd be 1. So our next subnet would be 10.67.83.160. And it's important just to make sure that everybody's singing the same song about the mask. So we don't also include the mask. So that mask, /27 in dotted decimal would look something like this. 255 dot, oh, don't want to write over my face. It's like, that might be an improvement, Keith. The mask in dotted decimal would be 255, which means the first 8 bits of the mask are on. The second octet for the mask would be 255, which means the second 8 bits, or the second octet, all those bits are on in the mask. And the third octet of 255 means that I'm excited about writing 255. Means that the third octet in the mask are all on. So up to that point, that's 24 bits. And then for these 3 additional bits, we just take 128 plus 64 plus 32. Do it longhand, or you can memorize those after a while, but it'd be 224. So a /27, or this mask in dotted decimal, means the same thing. And then, in addition, what we can do, and this is pretty cool, good reminder, let me erase this for a second, is we could go ahead and we could calculate the ranges of addresses. And here's why that's important. We might want to set up a DHCP server with pools of addresses. And those pools of addresses would be the range for each of those subnets. Or if we wanted to assign the IP addresses manually on a server or on a router interface, we'd want to know what those ranges were so we could pick an IP address from the correct subnet. So because we have these 6 subnets already listed, it's pretty simple to go ahead and just identify the ranges. It means simply starting with 1 and then going almost all the way up to the next subnet. And that's the magic. So it goes something like this. For this subnet, subnet A, it would be, I'm just going to go for the last octet. So the first 3 octets are going to be 10.67.83. That doesn't change. That stays the same. And the last octet here for the host range, I'll put range here, host range, it would be .1 for the first host on that subnet. And then here's the challenge. If we used .32 for that, as a IP address in that subnet, that's the address space for the next subnet. So it's like you can't go to your neighbor's house and just say, hey, I live here too. It's like, no, you don't. This is my house. That's your house. And that's the same thing with IP addresses. IP addresses are going to be in a certain range. So this range would go from .1 all the way up to 31. And I'll put that here. And that is the broadcast address for this subnet that we're looking at. So the range would be starting with 1 and going up to the next subnet -2, which is because the last IP address is the broadcast address. The last usable address, which is going to be .30 in this case, is what you could assign to a host. Now, this is a fun trick, not trick. This is a fun game. If you tried to go to an interface on a computing device that supports IP addressing, and you said, I want your IP address, Mr. Windows PC, Mr. Linux PC, Mr. Router Interface. I want your IP address to be 10.67.83.31 with that /27-bit mask. It's going to say, not a valid host address. It knows, like, immediately. It's like, who told you? Those darn computers, super fast. All right, so the next subnet, 32, would start with .33. So .32 is the actual street name, like Elm Street, and .33 represents 1 bit on in those host bits, the first bit on, and that would be the first valid host address on the 32 subnet. And the range would be all the way through 64 minus 2, and that's because the next one minus 1 would be the broadcast address, and that would make it, I'm all sideways here. Yeah, I need to raise that up a little bit so I line those up. So .63 would be the broadcast, and the range would be .33 through .62. And that would just continue. And then you could know that. Now, we had a session on routing yesterday. Oh, I take it back. Today's Saturday. In our last live stream, we had a session on default routes. Now, that was 2 sessions ago. It's all a great blur for me. It's all a lot of fun. In the last session that we had on why do routes have to win twice, that was it. We looked at the routing table, and we were able to determine, okay, based on the longest match, which route would be used, and this is the technique that we could use to do that. So if we had several routes, we could actually plug in an IP address and see what range they fall in and then determine that. So this game continues on now, and we can just follow that same logic all the way down. Now there's a huge, did I say huge? I would say pretty big problem with what we just did. And that is, so we rush back to headquarters. We say, great, we have 6 custom subnets, and we actually have room for 2 more. We only use 6, and we're all good to go. And then they said, well, did you plan for how many hosts you need? And we might say, what? Well, wait, hold the phone. What do you mean, did we plan for how many hosts we need? And they said, well, on one of those subnets at the branch office, they're going to need to support 80 hosts. So we look back at our notes, which we'll do right now, and we say to ourselves, Houston, we have a problem. And here's the problem. We only have this many host bits available. 1, 2, 3, 4, 5. And so my question for you is, if we have 5 bits available for host addressing, how many possible hosts can we get out of that? It's the finger game again for quantity. So let's do that together. And I'm going to leave myself on this little camera, and let's do the finger game together. And with 5 bits for host addressing, put a thumb up in the air and say 2. We're looking for 5 bits. That's where we're going. So 2, 4, 8, 16, 32. So 5 bits gives us 32. Oh no. And then you have to subtract 2 because you can't use the actual network address and you can't use the broadcast address. So with 5 bits for host addressing, we can only support 30 devices. And corporate says, so we go to corporate, well, we can't support, the IPv phones or whatever else devices you needed in that first VLAN, and they're going to say, make it work. And with what we just did, which is using the same exact mask across all networks, we're wasting IP addresses because some of those subnets may only need 5 IP addresses or 10 IP addresses. Some may need 80. And what we've done here, and let me go ahead and draw this out. This is why I put a pizza on the banner for this session, was because what we just did is this. We created 8 new subnets. So this is the parent network, 1067.83. And what we did is we have the ability now to divide that into 8. So network A, B, C, D, E, F. That's all we needed. And then we have a couple other subnets that we aren't using in our topology yet, but we have room for. But each of those subnets only support 30 hosts each. So that's like an equal distribution. And if we need 80 hosts here and we need 10 hosts here, they're based on how we carved it up, it's not going to fly. We don't have enough host bits in that subnet A. So here's what we're going to do to solve the problem. What we're going to do is we're going to do a slicing of the pie. Think of the whole network, 10.67.83.0, with a 24-bit mask that as one large piece of pie, that address space. And what we're going to do is we're going to carve it up, but instead of doing equal slices, we'll carve out some bigger subnets for the benefit of networks that need more hosts. That's it. And for subnets that don't need as many hosts, like 5 or 2, we'll just make teeny little slices. And that's all done by using a different mask at different points in the network. You might even call it varying the length of the mask. So we'd have a shorter mask for networks that need to support like 80 hosts and longer masks for networks that need to support 2 or 5 or 10 hosts. So we need a cool term for that. what would that cool term be? That cool term might be variable length subnet masks. That's what it means. And it's important because we do have to have situations where we can make it work and not waste IP addresses. And so what I'd like to do is take our knowledge that we currently have a block size, which either you have already or you're going to go back to the playlist and come up to speed with that, and also the finger game for quantity. And I'll show you and we'll walk through together on how to configure variable length subnet masking to make it work. So that was our two goals, by the way. One was to understand why we need it, because in this scenario, we don't have enough address space for hosts. And secondly, how to do it, which is coming up. So let's clear this board. Boom, all that work. Oh, my heart goes out a little bit. It's like, oh, all that cool stuff that was on the board, gone. And let me bring up a tool that we can use also that can help us in this discussion. And here's that tool right here. And just thinking through this for a moment. All right. So one of the things that we'd want to do before, this is important, before we just go out and start carving out subnets. Oh, here's 8 new subnets. Oh, not enough room for hosts. So sorry. First thing we'd want to do is identify how many subnets we need and how many hosts are supported or do we need to support on those networks. Now, IP addresses for a subnet, there's a good chance we're going to overlook a few by default. Router interfaces, they need a valid IP address in those subnets. IP telephones, if you have a VLAN for phones, they're going to need IP addresses, and probably a lot of them. Internet of Things devices, they're going to need an IP address. Things like cameras and refrigerators and other things that may be internet connected or network connected to your network. Things like printers, if they're network-based printers, they're going to have an IP address. Other devices, especially in wireless networks where people are joining, you might have tons and tons of devices that are trying to get on the network, and we need to plan that out in advance so we make sure we have enough space, host bits available, and the range of addresses that will support the expected number of clients or devices on that network. So we've done some research, and in this topology, here's what we found out. We found out that for subnet A, they need 80 hosts. That's what this column is right here. How big? Meaning, how many hosts, how many devices need actual IP addresses, whether they learn them via DHCP or whether we're statically configuring, what's the total number we need? And we came out to the numbers of 80 for network A, 30 for B, 20 for C, et cetera, et cetera, et cetera. So now we have our requirements, and we could say, also we might want to challenge the design a little bit and say, now, is it going to grow beyond 80 within a year or 2 years? Because we don't want to have to come back and revisit this and readdress. I remember I worked at Paramount Pictures in like 94, 95. I believe that time. It was like the time I based it on when movies came out. Forrest Gump, whenever that just came out, that's when I was at Paramount Pictures. And great opportunity at Paramount Pictures. Loved it there. And we got bought by Viacom during that time. And when two companies, they don't partner, it really Viacom purchased Paramount Pictures. We have to make everything work, and there's a lot of readdressing and NAT translations they have to go on while we're doing the migration. But the key is we want to plan it once well and then roll it out so we don't have to readdress it in the future. So I'm going to go ahead and clear the screen off with some of those markings, and let's imagine that this is our plan. And when we're given a specific subnet range like this or a network address space to play with or to work within, it's important for doing variable length subnet masking to go from high to low. Start with the subnetworks that are going to require the most hosts first, and then work your way down to the second one, and the third one, and the fourth one in descending order. That's important. That way you're not going to waste IP address space as you go. Also, realize that in a bigger picture, we're going to have some cool games with summarization and making addresses summarized based on branch and location, which we'll get to. Not in this session, but we'll get to in Subnet Saturdays, and we'll make that all work. But our focus here is how do we do variable length subnet masking to support these 6 networks, and each of those networks having that many hosts. So I'm going to clear the screen once more, and let's do it. And you might say, well, Keith, how do we start? How do we start doing this? And first of all, we have the data we need, and the next thing we might want to do is say, okay, well, let's start with what we know, like a word problem. Sometimes getting started with something is just taking some fixed value and then working from that way. So if we're doing variable length subnet masking and we need a network that's going to support 80 hosts, let's imagine it's right here, network A. In fact, it is. There's network A. We need to support 80 devices on that subnet. My question for you is this. How many host bits do we need to support 80 individual hosts on any network? I don't care if it's a class A or a class B or a class C or any what the numbers are. How many host bits at the end of an IP address do we need to leave available for host addressing? And so if you're saying, wait, this is like a quantity game. It is. I'm asking you, what's the quantity of host bits? Little help there. What's the quantity of host bits we need to leave available to support 80 hosts? So we play the finger game. Anytime we need to know how many bits, whether it's subnetting or host bits in this case, put your thumb up, there's a 2, and we want to get to 80. So 2. That means 1 bit is not enough. Double as we go up. 4. That's not enough. 8, 16, 32. What were we going for again? Oh yeah, 80. So we have 5 bits would get us 32. Not enough. Another hand. Another finger. 64. Oh, 6 bits. Still not enough. Another finger up. 128. 128 seems like a lot, but 64 won't do it for us. So we need 7 host bits to get at least 80 hosts. We need 7 host bits. And that means at the tail end of our IP address space with the mask, we need to tell the mask, hey, buddy, you need to leave 7 host bits for host addressing. So let's look at that visually. It would look like this. If this is the 4th octet from our mask, right here, I'll just label that. So the 3rd octet goes that way, 4th octet goes that way, and there's 24 bits that are currently on. We need to reserve, and I'll put these in a nice blue color. We need to reserve all these bits. Let me just count. Let's count together. We said 7 bits. I'm going to just do that math again. 2, 4, 8, 16, 32, 64, 128. Yeah, we need 7 bits reserved. Just making sure I said the right thing. We need 7 bits available for host addressing. So 1, 2, 3, 4, 5, 6, 7. So the mask, if we use the longest possible mask, which would be 24 bits on here, plus 1 bit on there, these would be zeros in the mask. Which means, line them up, Keith, line them up. You got people watching. So 0, 0, 0, 0, 0. This would be the mask. And that's required. I mean, there's not too many options there. We have to leave 7 bits available for host addressing. So if we had 24 bits all the way up to this 3rd octet on in the mask, plus this one, the new mask would be how long? How long would the new mask be? If you're saying, Keith, well, if it's going to be all bits on up to this point right here, that's going to be a 25-bit mask. And so that's going to be the mask for our first subnet. And when we take a look at the first subnet, we're just going to bring down the parent network and plug it in, which is 10.67.83.0 with a 25-bit mask. Now you might be saying, well, Keith, that looks remarkably similar to what we just did before. And it is, same game. Same game. We put the mask in and we identify what the mask is going to be. The first network looks like the parent network except for a longer mask. And let's also jot out the dotted decimal mask. So 25 bits would be the first 3 octets of the mask would be all on. And then it would just be this 1 bit right here on the mask that's on and the rest off, which would be 128 plus 0, 0, 0, 0, 0, 0, etc. And the mask in decimal would look like this. And you might say, well, why do we need to know that? Well, that's how you got to put it in. So if you're configuring a Windows computer or Macintosh or a Raspberry Pi or a Cisco router or a switch virtual interface on a multi-layer switch or on a layer 2 switch, you have to put in the dotted decimal mask. And so that's how we would, when we configure an IP address, that's how we would do it. We would put it in dotted decimal for the mask. The next piece is, what is the block size? And this is going to be important because we're going to use it. What is the block size if the least significant bit, which is right there, that's the least significant bit in the mask, what's the block size for a /25? And I'll give you a moment to think about that. We had a session just on block size, and we identified that, hey, the block size is the value of the least significant bit. We follow the bits all the way in the mask that are on. We find the last one in the mask that's on, and that corresponds to the block size. And the block size, as I'm looking over here, you guys are rocking. Fantastic. The block size is 128. All right, now how's that going to help us? Well, if we know the block size, hold on to your hats. What would the next subnet be right here if our block size is 128? And let me give you a chance to think about that. What would our next subnet be if the block size is 128? And you might be saying, well, Keith, you just talked about that a few moments ago, and in our discussion on block size a couple sessions ago, you said you just add the block size. Yes. Check this out. So the next subnet, no matter what the mask is going to be, doesn't matter. The next subnet is going to be a 128 in that last number, because we take the parent network here, the first one, and we simply add the block size. And I'm going to clean that up a little bit so it's very readable. Just like that. So then the question might be, well, since we're here, why not calculate the range of addresses for this 10.67.83.0 network with the 25-bit mask? Well, we know the first address is going to be one more in that last octet, so it's going to be .1. And we know the next subnet, check it out, it's 128. So we can't use 128. That's like the next house. It's like my house belongs to this is here, your house is there, and we have to stay in our lane here. So we can't go higher than 128. So the broadcast is the next subnet minus 1. So the broadcast for this first network is going to be 127. And the last valid host address is the broadcast minus 1, which is 126. So you could say the last host range is, the last host IP address is the next subnet minus 2, that works. Or you could say it's the broadcast minus 1, that works. Or you could say that the broadcast is one less than the next subnet, and then any way you want to slice it, that's how it works. And now we have our first range, so we could set up our DHCP server. We could specify any IP address between .1 and .126, and they would logically be in subnet A. That's how that part works. Now, let me also draw a visual for you here, and we'll put it right here. I'm going to compare this block of addresses, the 1067A30, to a pizza. Now, when we did subnetting earlier, what we chose to do was we used exactly the same mask across all of our subnets, and we had 8 possible subnets, 8 identical pieces. Now what we've just done, and this may come with habit, but the maximum number you can get out of one octet is 255. And so we just gave 1 through 126, which is about half. We just gave half of the pizza over to subnet A. And that's what that is right there. So we needed to, because we have a bunch of hosts that need to fit in that space based on our calculations earlier. So our next question is, okay, that range of addresses, basically 1067A30, which goes from .1 through .127, including the broadcast, that's all tied up, and it can't be used by some other street. This is already in use. That piece of the pie has already been gone. Let's take a look at the next subnet, which begins 128, based on the block size being added to the network. And let's go ahead and do the calculation again for how many host bits do we need for network B. That's the question. And I know here it says we need 30 hosts, but it totally escapes me on how we would possibly figure out how many host bits at the end of the IP address we need to leave in reserve to support 30 hosts. It's just, how do we do it? Where is this, voodoo magic? How do we calculate the number of host bits needed for 30? And if you're saying use the finger game for quantity every single time, we would be right. So let's calculate how many bits we would need for 30 hosts. So we put up our first digit. It has a 2 on the back, and we're going for 30. 2, 4, 8, 16, not enough, 32. And because we have to subtract 2, because you can't use the network or host address, our network address or broadcast address, we could actually use 5 bits for host addressing and have 30 available host addresses. Is that true? Let's do it again. So 2, 4, 8, 16, 32, minus the 2 because we can't use the network and broadcast. Yeah, all we need to do to support 30 hosts is make sure at the end of the day we leave 5 host bits available for host addressing. So let's apply that newly learned information to our variable length subnet masking plan. And it works like this. And I will get out my eraser tool, which I've started using, and All right, now we're focused on leaving 2, 4. I'm doing the math again. 2, 4, 8, 16, 3. We need to leave 5 bits for host addressing. So that I'm going to circle here. 1, 2, 3, 4, 5. We need to leave these last 4 bits for host addressing. That means our mask would be 24 bits up to this point, and it would be on. We just basically, the mask is going to say, I'm going to take all the network address space except for how many hosts you need on that subnet, which in this case is 1, 2, 3, 4, 5 bits. So there's the dividing line between network and host for this specific subnet, and we want to represent that down here. So what is the new mask? It'd be 24 bits here plus 3 more, 5, 26, 27. So we just bring down that mask, and that's our network. I wish it was tougher, but that's our network that'll support 30 hosts. It's the 10.67.A3.128 network with a 27-bit mask. We're going to do this 2 or 3 more times in the same table to help reinforce that. So what would the mask be in dotted decimal? Well, it'd be 255. The first 3 octets would all be on, 24 bits. And then how do we represent these last 3 bits for the mask? It'd be 128 plus 64 plus 32. And you can just do that longhand. That works. Just, 128, 64, 32, and that would be 224. I'm just looking at that, verifying that that would be true. And that's just because I've done that a few thousand times. But that's the addition between 128, 64, and 32. Great. So that's the mask. And now my question for you is, what is the block size for a /27? What is the value of that least significant bit in the mask that is on? And I'm going to, if you're posting that, rocking, I'm squaring it off right here, is 32. The block size, and you know what, the reason we call it a block size is because that's the size of the block of addresses that we get to play with. It's it's kind of a little pun after you've done it a few times, but that block size represents a block of addresses that are supported by that network. All right, so the block size is 32, so we put it here. And then something that we have never covered before, how would we know what the next subnet is if the block size is 32 and this is the network we're working from? And if you're saying, Keith, no. We've done this before. You told us like sessions ago that you take the network, you take the block size, you add the block size, and that's your new subnet. That's still true. You got it. If I was trying to fool you, didn't work. That's exactly how it has worked. That's exactly how it still works. And that's how it will continue to work in the future. So the next subnet would be 128 plus 32. We'll do the long math there. 8 plus 2 is 10. Carry the 1. 3, 4, 5, 6, 160. So the next subnet would be 160. And now that we know what the next subnet is, the range now becomes easy to solve for subnet B. And that is, here's the network with 128. The first valid IP address is going to be plus 1. So it's going to be 129. And then the last subnet, or the last IP address in that subnet, is going to be the next subnet minus 2, or the broadcast address minus 1. And so we can work it either way you're comfortable with. It's going to come out the same each time. So the next subnet is 160. So minus 1 is 159 for the broadcast address. Minus 1 more is 158. And there we have our range. .129 through 158 for this network called 10.67.A3.128 with a /27. All right, nice work. Good job. We're doing variable length subnet masking. Now in a production environment, we'd simply use a calculator for this. You put in your network, how many subnets you need, how many hosts you need, you hit a button, it spits it out, and you're good to go. But understanding how it works and being able to do it on demand is an important skill, because you may be reverse engineering something, and it's so important to understand how this works. And if you're in certification and they're asking you about, hey, you've got a host on this IP address based on these 5 routes in the routing table, which one matches? And the only way to figure that out is to do this process. And so it's very valuable on several fronts. I'm glad you're here. Let's take a look at the next subnet, subnet C. We need 20 hosts. I'm going to go ahead and clear up a little bit of work here. And that's this. This was all based on that /27 we just did. So let me clean some of that up. Oh, we can also add to the pizza. I like pizza. I do. Carb City. And so for network B, it got a smaller slice here. So we just gave network A a big slice to support 80 hosts. We gave network B a smaller slice to support 30 hosts. And now we're going to go to 20. So for 20, my question for you is, and this is no longer a running joke, now it's just common knowledge and getting more comfortable as you do it a few times. If we needed to support 20 hosts on a given subnet, how many host bits would it take to leave available for those hosts so we'd have enough room? It's like the sign maker just trying to leave enough room for the house addresses. How many bits would we need to leave available to support 20? It's the finger game once again. So we're trying to go for 20, 2, not enough, 4, not enough, 8, not enough, 16, not enough, 32, well, and then minus 2. So we have to have 5 bits. Again, so we're going to have some wasted space in that subnet, but if we want to support 20 hosts, we have to leave at least 5 host bits. Because we did the work for that one on the previous example, it's going to be a little faster on this one. So we know the mask is going to be /27 again, same mask. We're leaving the same number of bits, so the mask is going to be the same here too. The block size is still going to be 32. And let me just verify that real quick. Yep, I just want to make sure I'm not going down the rabbit hole. And then our host range would be, if we take a look at the host range, it would be the subnet, which is 160. So you and I could talk to each other and say, hey, this is subnet 160 in slang. Or long term, we could say, hey, it's network 10.67.83.160. But if you're working on a network for many months or years, sometimes you might refer to those networks as the last part that are unique. Or you may call it the sales VLAN, because usually an IP subnet address is associated with a layer 2 broadcast domain, a VLAN. So in production, if people say, oh, it's the sales VLAN, or the human resources VLAN, or the development VLAN, they're really talking about a layer 2 broadcast domain that has a layer 3 IP address, and they may be just referring to that network address space on top of that VLAN. But that's how it works. So 160 is the network. The first valid IP address is going to be before we go there, what is the next subnet? Let's do that. What is the next subnet going to be for D? And this uses the game of you take the existing subnet, you take the block size, you add it, and that's the next subnet. And so it would be 160 is the current subnet plus 32, and we would have 291.192. I believe that's correct. And so we'll just put in 192 as the next subnet, and that makes it helps us configure the range. So the first valid IP address is going to be the subnet plus 1, which is 161. The broadcast is going to be the next subnet minus 1, which would be 191. And then the last valid host address is going to be one less than the broadcast, which is 190. Just like that. All right, we're making progress, and there is some repetition here, which is a good thing. It means that we're having the opportunity to rehearse the process for doing this. And so the next subnet I'd like us to go ahead and tackle is subnet D. Now subnet D, let's draw on our pizza. So B and C got equal size slices right there. Bonk. All right, so we're carving out the pizza. Now at some point, we are going to lose the ability to hand out any more IP addresses because we're going to use the whole pie. Once that entire block of addresses is used, the 1067.83.0, and all of its possible subnets and IP addresses and bits are in use, we're going to run out of space to allocate anything else. So that's also a question that goes into the design is, can we do this? So previously, when we carved this up into 8 equal subnets, we couldn't support 80 hosts. But now, because we have some other subnets that need less hosts, and we're using variable length subnet masking, we can go ahead and pull off that task. So let's do the next network of D, and we need 10 hosts. So my question is, regarding the bits in that last octet, how many bits do we need to leave available for host addressing if we want to support 10 hosts on a given network? So let's go ahead and do the math together. It goes something like this. Our goal is 10, 2, 4, 8. Oh, not enough. 16 is enough. So 16 minus 2 would be 14 available host addresses. So if we want to support 10 host addresses, we need to leave 4 bits. Same game as before, just quantity. In this case, how many host bits? So let's go ahead and do it. And let me get my eraser out and clean this up a little bit. And we'll focus on 4 bits and see what that looks like visually. So we need to save these 4 bits for host bits. And that means the mask, as it has 24 bits on up here, we could actually have one there, one there, one there, one there, and then tell it to leave those 4 host bits alone. Just to verify that 4 host bits is enough to support 10 IP addresses, 2, 4, 8, 16, yep. So 4 bits will get us a total number of combinations of 16, but because we can't use the all zeros, the network address, or the all ones, which is the broadcast address, we subtract 2, but that'll give us 14. 2, 4, 8, 16, yeah, gives us 14 valid hosts. So let's do it. Let's put in the values here. The network is going to be 1067.83.192. The new mask is going to be 24 plus 1 more, plus 1 more, plus 1 more, plus 1 more. So that'd be 24, 25, 26, 27, 28, based on our math here. So that's going to be a /28. And what is the block size for a /28? It's the value of the least significant bit in the mask that's on. And so in this, for a /28, it would be this bad boy right here. So just for visual purposes, I'm going to put the block size here. And what would the next subnet be if we have a block size of 16? So we're starting with 192. The next subnet is 16. Or sorry, the block size is 16. Do the math is what I'm telling myself. 192 plus the block size of 16. That'd be 8. 9 plus 1 is 10. Carry the 1. That'd be 208. And there we go. Our next subnet, as I go to the mic, our next subnet is going to be 208. And we'd put that right here. So the benefit of that is that if we wanted to know the range for the 192 subnet, we would simply say, well, the subnet's 192. We add one more in that last octet to make it 193 for the first IP address. The next subnet's 208, so that means the broadcast for this subnet, Subnet D, is going to be 207, and the last valid host address is one less than that, which is 206. And we could write that out also for the mask in dotted decimal. So the mask would be 255, 255, 255, and then these 4 bits that are on would be 128 plus 64 plus 32 plus 16, which is a whopping 240. And those numbers for the mask are going to become more comfortable to you as you work more with them because they have to be in order. With a mask, you're not skipping bits. It's not going to, I'm going to take the 128-bit and the 32-bit and leave the 64-bit off. Masks are contiguous. So the values would be 0, or 128, 192, 224, 240, 248, 252, 254, and 255. Anyway, that's just from a matter of, now in my mind, I was actually visualizing those. So people remember things differently. And so it's not important you memorize them, but it's important to be able to calculate what they are. So 4 bits on means 128 plus 64 plus 32 plus 16, which is the 240 right here. Great. So we just gave a smaller slice to D. So I'm going to go ahead and put down here D. D just got its slice of the pie. And these arrows are just these arrows are now lame because they're all over the place. Let me fix that. All right. So I'm corresponding these letters of the subnets to the individual portion close to the proportional slice of the pie that they're getting. So let's finish this off. Now we have subnet E. Subnet E begins with 10.67.83.208, and let's calculate. Let's calculate together. If we need to support 5 hosts, how many bits do we need to leave for the hosts? Let's do the game. 2, 4, not enough. 8 minus 2 gives us 6. So basically 3 bits, 3 host bits is what's required if we want to support 5 IP addresses on a subnet. So we need to leave 3 host bits at the tail end. So we can do that. Get out my pen here. And it would look something like this. All right, so what did we decide? I was just erasing, got so excited. 2, 4, okay, 3 bits. So we need to leave 3 bits for host bits. And that means the network can use the rest of all that space if it wants to for network addressing. So the mask would be 24 bits on the mask there up to that point, plus 25, 26, 27, 28, 29. And that means we'd have a 29-bit mask, which looks like this. That's what 29 looks like in decimal. And what it would look like in dotted decimal would be 128 plus 64 plus 32 plus 16, which is 240, plus 8 more would be 248. So our mask would be 248 in dotted decimal. That represents that those 5 bits in that last octet are on in the mask. it would also mean that our block size is 8. So we write that down here. And what would the next subnet be? If you're saying, at this point, you might be saying, oh, Keith, I think I got this. This is the same game repeated over and over, just with the new mask. What's the next subnet? What's the range? And continue. That's exactly right. It's the same process, just how many bits are needed, what's the longest match possible, and then identifying the next subnet based on the block size and continuing down. So the next subnet would be 208 plus the block size, which is 8, and that is 16. That'd be 2. So that would be 216 is our next subnet, and that allows us to configure our range. So the network is 208. The first IP address is always one more. So that'd be 209. And the next subnet is 216, so our broadcast is going to be 215, and our last available host on that subnet is going to be 214. As I look at my work here. Yeah, that looks correct. So not very many host addresses there, but we only need 5. And so let's go ahead and continue that discussion for network F. You might be saying, well, Keith, network F is the same requirement for number of hosts, so the mask is going to be the same as up here. It is, true story. And that means the dotted decimal representation of the mask is going to be the same, true story. That also means the block size is going to be the same, true story. And then the range for this one, because the network starts at 216, the range for that network for valid host IP addresses. And this is important if we were going to use a DHCP server, set up pools of addresses, or we have to know which IP addresses to assign to a computer on that subnet. This would be the range. It'd be the network plus one more, 217. And then for the ending part, here's what we could do. We could cheat a little bit. And what would the next subnet be after 216? And if you're saying, well, Keith, you just had the block size, and that's true. So we'll add 8 there. So that's 4. 8 plus 6 is 14. Carry the 1, that's 2, and then 2. So it'd be 224. And maybe we don't need that network, but it does help us to calculate what the range would be for the previous one. So for this network here, it'd be 217 for the first IP address, 223 for the broadcast for network F, and the last valid host address would be one less, which would be 222. Looking at my work, and that looks correct. So it does take a little, as I presented this, let me give you an insight to what I wanted to do. I first of all, I was just going to do this all freehand and write out the networks and how many hosts were needed. And then I had some feedback about 2 months ago, early on, as I started doing regular streams, like every Wednesday and every Saturday and every Sunday. And one of the comments was, you could have clarified that a lot more by having a little bit of a table present or a little more. So there's a lot of forethought that I give into these streams. Like, how do I get the information from my head and my experience into your soul so that you can interpret it or ramp up and really become good at those things that are important to you. And that's why I created this table. So I went over the table. Actually, this is my 4th or 5th different mechanism regarding what should I show on the table, how straightforward or how challenging should it be, and this is like the 4th or 5th attempt at getting that done. So that's what you're seeing here, is what I think was be a great representation of all the techniques we've learned, counting with the finger game, the block size, calculating the new subnet, and then based on how many host bits you need, which is the big part of variable length subnetting, leave enough host bits for each of the subnets. And when you work from your biggest networks down to your smaller ones, that technique works great, and it doesn't waste any IP addresses. Oh, let me go ahead and pick up a call from headquarters. Ring, ring. Yeah, we got all the subnetting done. Yeah, me and about 100 people live streaming right now. Yep, we're all set. No worries. What? You need one more subnet for the WAN connection to us? Okay, I'll ask the team. We'll take a look. Thanks. Bye. Okay, so I just got a call. Just got a call from headquarters, and they're asking us if we can fit one more network into this scheme, the variable link masking, so that they can support the WAN connection to us. Maybe it's Metro Ethernet or some kind of service provider Mpls service, but all they want is a direct peering. So a service provider can play a lot of games. They can make us at our branch office appear adjacent to somebody who's geographically remote, like hundreds of miles away or thousands of miles away, just by giving us layer 2 connectivity over their network. So what headquarters has asked us to do is to say, can we do one more subnet to support effectively a network that only has 2 devices? So it's going to be our router and their router over the service provider network. And let's take a look together and see if we can do it, because this is another application of this in the real world that we want to be familiar with. I'm going to erase a little bit so I can have some. I'll put my camera on there. All right, the pizza's gone. The longhand math is gone. And let me go ahead and clear that off too. All right, it's so I don't know, feels so good to just clean stuff up occasionally. All right, so we have this network plan, and it's going to work for our network. And let's draw in some connectivity right here through a service provider cloud that's going to connect us to HQ. And all we need is one IP address for here and one IP address for here. And the first thing we're going to say to our headquarter people is, why didn't you tell us earlier? We would have put that in the plan. But we have some space left. We haven't used up our entire addressing space. So let's go ahead and create network WAN. So maybe this is going to be deployed and rolled out with software-defined networking or pushed out to the routers. It doesn't really matter. We still have to know what the IP addressing scheme is going to be so we can have the network push it out. So for our WAN connection, that's going to go off of, let's say this is fast Ethernet 4/1 here, going down to headquarters. We need a network, a subnetwork in this space that supports 2 devices. Oh, wait a sec, 2 devices? I know this game. How many host bits do we need to leave to support 2 hosts on a network? 2. Oh. Now, if you're in CCNA world, that's not enough, because there are some corner cases where a point-to-point circuit, you can actually use the broadcast and network address. But for the purposes of general CCNA, if we have 1 bit for host addressing, that's 2, but you can't use the network address or the broadcast, and that means you're down to 0. So if we use our finger again, let's say 2, and then another bit for 4, and then reduce the 2, that means that effectively 2 host bits at the end of our IP address available for host addressing is going to provide us 2 valid IP addresses. So 2, 4, minus 2, because you can't use the network or broadcast address for valid host addressing. That means we need to allocate 2 bits. We can do this. We have the technology. We've done it like 6 times. We're going to do it one more time for our WAN circuit with another variable length mask based on a requirement of only allowing 2 hosts or needing 2 hosts on that network. So we did the finger game. So we know that we need to leave 2 host bits. Great. That's in stone. And that means that we can have all these other bits for the mask be on. And the mask would say those last 2 bits are host bits, and they're available for host addressing. So we're starting here at the 224 network. So what is our new mask going to be? If there's 24 bits on here, plus 25, 26, 27, 28, 29, 30. That's a /30. Nice. And in dotted decimal, that'd be 255.255.255. And then you could do 255 minus 3. That would work. 252. All it is it's 128 plus 64 plus 32 plus 16 plus 8 plus 4, which is 252, which represents a /30 mask. And then the question would be, what is the block size? This is a great game. It's the game that never ends. It just goes on and on, my friend. Soon you'll be custom subnetting with nobody. Okay, so what is my question? Oh, what is the block size? What is the block size if we have a /30? And if you are saying, Keith, got this cold, it's the last bit on in the mask. That value, which currently is 4, that's the block size. So we're going to put that in. That's our block size. And then for the benefit of range, what would be the next subnet after 10.67.83.224? What would be the next subnet? And if you're saying, Keith, well, this is almost old hat now. I mean, we've been through subnet Saturday, session 1, 2, 3, 4, 5, 6, 7. Now we're here at 8. It's adding the block size every time. Just add the block size. Okay, there's the block size. There's our network, 228. So that's 224 plus 4 more. That's our next subnet. So if we know the next subnet, that means the range for this new WAN circuit, this new WAN subnet, which is supporting 2 hosts, would start with the subnet ID, the network +1, which would be .225. The broadcast for that network would be .227. It's the next subnet -1. And the last valid host address on that subnet would be 1 less than the broadcast, which would be 226. Those are indeed the two hosts that are allowed, that would work on that subnet, which is the 10.67.A3. So we call back headquarters and we say, yeah, no problem. Boom. We have this network for you. It's the 10.67.A3.224 network with a 30-bit mask. And then you can toss a coin. Does headquarters get .225? Or do you? Or do we? Or does headquarters get 226 and we take the other one? And then you'd put the IP address there. So it'd be 10.67.80. Oh, come on, Keith. That's my CCIE number. I should be able to remember that. So on this interface, it'd be 10.67.83.225. We'll take the first one. Slash, and it'll be a /30. And then over here, they would take .226 on that same subnet, and there's no more room. There's no more room on that subnet, but we don't need any more room. It's a point-to-point link. There's only two devices that need IP addresses, and there we go. And we're not wasting address space. And we have a little bit more space in our pizza. So we gave half the pizza to network A. We gave a big chunk of the pizza, equal chunks, to B and C, a smaller chunk to D, an even smaller chunk to E and F, and then we gave a very tiny chunk right there over to the WAN circuit. And we still have some room left. Let me compare my notes and make sure that these are all correct, because that would be important too. I'm just going to look at the broadcast addresses. Okay, good. And one more thing I would check, 128, 224. And the reason I want to check this is because if I put this up for posterity, I want to make sure that every single person who looks at it is getting the accurate scoop. Yeah, it's correct. So it's correct with your help. I appreciate it. That's the process for doing custom subnetting and variable length subnet masking within a very confined address space that we were given. And as we continue in our journey together with Subnet Saturdays and with CCNA in general, we'll take a bigger approach at the headquarters office. What are they doing? Why did they give us this address space? And how we can do things like summarization and some other techniques that are used in production networks and the internet to make the networks all manageable. So that is it for me for the lecture part of this, for this discussion I've had with you regarding variable length subnet masks. Couple tips. Number one, if you are new to subnetting, I welcome you to encourage you to join us for the playlist. It's called the Subnet Saturday playlist. It's on my Keith Barker YouTube channel. Grab it and just go down it in order and make sure you're comfortable with all those topics and techniques. And that will, when you hit this one, if this was your first one, it's a whopper. So when you eventually get to this point, you'll have the skills of the finger game, the block size, binary, the mask, how it works, and you'll be more comfortable and prepared to tackle all of this. Also, if you need a refresher, or if it's your first time through the whole series, you might want to take a second look at that and enjoy it. And we're going to be using it. And this applies so many places in routing tables, which route is going to be matched. It applies when you're trying to figure out, okay, here's an IP address. What subnet does it live in? And so we'll cover that in specifics as well as we go forward. So I'm going to take a short break, a very short. And then if you want to stick around for some Q&A, here's my request. One is, first of all, I want to thank the moderators and everybody who's been answering questions and helping out. Oh my gosh, it's been so great. I've seen a lot of answers going over here on this Q&A slide of the chat. Thank you very much. I'm so glad everyone's here. So for the questions, which we'll cover in just a moment, if you have questions regarding variable length subnet masking or anything in these Subnet Saturdays that we've covered up to this point, I would love to go ahead and get those questions. If you don't have any questions on that, but have questions related to CCNA 200.301, that level from any of the domains, please feel free to ask those. Also, if you've asked questions earlier, instead of scrolling through the whole history, I'm just going to go ahead and look at the new questions that have at Keith Barker. So if you do it at Keith Barker, select my name, and then I can easily see them. I don't want to miss anybody. And that'll be an easy way for me to not pick up on somebody else's conversation. Now, when we come back from the break, too, and we have a chat, and I'm answering questions and talking about a few things, I have a couple cool things I'd like to share with you and talk with you about. One is I'm up in my game. I'm going to build this is a recording. It's a house here in Las Vegas, Nevada that I rent. And I rent it primarily for just content creation. And I work full-time for CBT Nuggets, as most of you know, and this is my full-time gig. I'm going to be moving this studio to my my other house, to my house where me and my wife live, and we're going to create what used to be a workshop, I'm not a carpenter type person, but we had this workshop with all these tools and a lot of room. It's like 14 feet by 19 feet, I think. So it's pretty big. I started gutting it yesterday, pulling cabinets off the wall, taking stuff out, just demoing it. And by the end of the year, my goal is to actually build a studio purpose-built with a couple areas, one for sitting and chatting, one for doing this kind of work, labbing and technical pieces, and also one for a space that I can do almost anything in that I can do for live streams. So anyway, that's exciting. I think I just told you all about that. I was going to tell you about that during the Q&A. Also, my son Paul, if you on Discord, which I invite you to join, by the way, it's a great place to chat and ask questions. On Discord, in fact, I'm just going to do it now, and then we'll take a break and go to Q&A. On Discord, we have 6 sections for recommended topics for videos, and they're all CCNA topics, like CCNA blueprint modules or sections. And then we had a request or an idea that came in saying maybe we create a separate category with 6 separate channels regarding questions and other discussions on those topics. And that way, if you have a request for, hey, I'd love to see a video on this or that, you can put it in the appropriate section, and that way I don't lose them. I can sort through those and pick and choose and say, okay, that'd be a great topic, let's do it. And then the separate channel, we could have a whole discussion area for questions and challenge questions like, what does this stand for? What's that? Just to kind of have fun and get the brain going and all the rest as you pursue your CCNA studies. All right. With that, I'm going to take a short break, really, really short, and just grab a drink of water. Be less than 30 seconds. Thank you all. If you need to bolt, please feel free to do so. And if you want to stick around for Q&A, I'd love to have you as well. And if this is your exit point, I'll see everybody in the next live stream or video. Meanwhile, I'll see you in a few moments for the Q&A. Thanks, everybody.
Life is a winding road, no telling where it goes. Driving through days and nights, won't stop for traffic lights.
All right, we are back. Whew, I have a lot of fun, so fun. I enjoy chatting with you. I enjoy taking your questions. I enjoy, for my own benefit, revisiting custom subnetting, variable length subnet masking, and every time I revisit it, it gets easier and easier. So I'm grateful for you joining me in the journey. And we've got about 100 people who are live right now, so to each and every one of you, glad you're here. I'm glad you're here. All right, so I'm just going to start looking now at any new questions where it says @Keith Barker, and I can go ahead and address them if there are. Let me adjust this just a little bit. Bring the mic over too, so, hopefully that's not too loud. All right. And if I don't see any questions, that's totally cool. I appreciate all the, I'm just scrolling back up. There's just tons and tons of questions and feedback, and it's been fantastic. And Darshan's saying, I enjoyed the pizza. Yeah, me too. And we have a few small slices left from our topology. All right. What if headquarters, Daniel says. Thank you for that question. Daniel's asking, what if headquarters calls back and wants a subnet larger than 4, now like 16? I had an issue with that, something that overlaps. Yep. So if sometimes you're going to have a network environment where it doesn't work, meaning if headquarters, for example, they wanted 8 subnets that supported 40 hosts each, and they only gave us a /24 to start with, there just are not enough bits to calculate, to have all those separate subnets and have the number of hosts they want. So if we try to create another interface on a router and we put an IP address, if it's connected to a network, and then we put another IP address on that router, another interface, that's part of that same network, it's going to say overlap. That's when you get that message that, hey, this IP address overlaps with an existing network, because you're trying to have two router interfaces in the same logical network based on the range of IP addresses, and that's why that message is popping up. So there are some migration techniques that can be used with secondary addressing. It's not pretty, but you can actually use the secondary option and apply a secondary IP address to a single interface. And then you could have two DHCP scopes, one for each of them, and then migrate them over. It's never clean or easy to do that. It'd be better to ideally have enough VLANs, have enough subnets and host space for all your anticipated needs. But that's why they have network engineers, because if we understand this and we say, okay, I have a interface I'm configuring, it says I'm overlapping. Why is that? It's because you're trying to put a second interface with an IP address that you maybe thought was in a different subnet, but it's not. It's in the same subnet that the router's already connected to. And that's where knowing the ranges and the IP addresses is going to help out. All right, Scott. Welcome, Scott. Glad you're here. Scott's asking, I'm not sure I understand why we should start with the largest subnet first. And here's what I have you do. As a great question. As an exercise, you can start with the smallest and give it a run. So what happens, usually starting with the biggest first just makes it nice and clean, a little bit better. But I would take this scenario that we just did right here and go ahead and do it in the reverse order. And it's just best practice, and you're not going to waste as many IP addresses if you do it this way. So you know what, Scott? I don't think that I have actually done this in the reverse order for probably many months, maybe even years. So I would actually, let me ask you this. Go ahead and give that a shot. Do it in the reverse order and see how that flows. Because I think there's some gotchas and possibly some wasted space that's going to come up as a result. But I wouldn't know that till I researched that further. So the best practice is to start with your biggest and then work down. And that's why I taught it this way. So if you take that as an assignment, I'd be absolutely excited about your results. That, hey, you can do it either way, it doesn't matter, and I'd be happy to pass that on. But best practice that I've always followed is start with your biggest subnets first and work down. Thanks for the question. All right, where can we find me on Discord? If I could have somebody in the room who knows that URL, or create an invite. If you're already in Discord, create an invite and post it here, that'd be great. I also will, as part of this video in the comments, I will post a link for the Discord server as well. So we'd love to have you. But chances are that somebody in the room is going to post that for me before I get there, but I'll still let it after the fact. Thank you for the question. Is the Discord up? Yes, it is up, Andy. So we'll get that link for you. And we're learning. I'm learning about rights and security. And I watched a lot of videos. I watched a video from like a 22-year-old guy. It was great. So I watched this video, I set it up, and then I made a change or two. I tore it all down, set it up again. So the one that's up now is like the second iteration. But I went and watched one of his live streams on Twitch, and it's amazing. He looked like he was 21 or 22. I went to his channel. I watched his stream. First of all, I liked it, and I subscribed to his channel. And I chatted, and I said, thank you very much. I just watched your like 40-minute video on Discord servers. I was able to set mine up, got a lot of great tips. Thank you very much. And he said, yeah, I'm glad you're able to do it. I love the fact that people are willing to share, tell people how it works. And the purpose of this channel is to focus on CCNA primarily, making sure that we're teaching content so that somebody can come in, not just have a good time, which is always fun, but also learn quite a bit about their stuff they're learning or studying. So in CCNA, sometimes you read a book or you watch some videos, you're just going to see one perspective. And by doing, in this case, we just did whiteboard for all the custom subnetting. But normally I do a hands-on approach to verify and show and demonstrate like default gateways. Remember that video? Whew, with proxy ARP that just kicked my butt. Anyway, I like to verify. That way a person watching can say, oh yeah, I get that. And I'm better understanding this and I'm having a good time with it. And I'm 55. I'll be 56 next month. And I love it. I love passing on what I know, and I'm always learning. So now my new learning thing is about SDN, which I'm having a blast. And let me share with you how I'm going to use that. In this channel, there's a whole module for CCNA on SDN. And I'm going to, first of all, not master it in the next few months, but get really good at it in the next few months to understand the pieces and the parts XML and YAML and RESTconf and NetConf and the APIs and Postman and Ansible and all those things and how they work and DNA Center and all the rest. And then I can boil down the important aspects regarding CCNA to really help you, if you're new to software-defined networking, to really get it. That's what I like doing. So that's my intent. Oh, Edwin's saying, what slices left are you referring to in the pizza? Let's take a look. So we have this address space here that we have carved up all the way through. The next subnet would be 228. Oh, let me get out a different pen. So the next subnet, let me get my face in there too. Hello. So the next subnet would be 228. So that's a slice left. So if we need more WAN circuits, maybe we have a backup circuit from R2 that's going out that needs to the network. The next subnet would be 228. There's our next one. And the block size would be 4. So 228 plus 4 is 232. That's our next subnet. So this one right here would be .229 through 230. And the broadcast would be 231. And that's an example in measurable terms of more slices that we have in the pie. Now I'm looking at that and thinking, is that our space? Yeah. So that'd be a slash 30. That 228. And that would be in our 10.67.A3.228. I was just confirming, yeah, we're not. So if you get past 255, there's a problem because the octet doesn't go that high. But that's what I meant by additional little slices that we have in our pie that we could use for IP addressing. Thanks for the question. All right, let me scroll up a little bit and pick the next one here. And here it is from Kenny. Hi, Kenny. Have you heard any feedback on the new CCNA exam? Anyone know who's taken it recently? How was it? So I haven't taken it yet. My intention is to wait just a few more weeks in case they have any bugs or issues with it. I have watched some YouTube videos from people who have taken it, and they are following the NDA, which is great. They're not disclosing what they did get or didn't get. So be aware of the fact that when you do pass, hopefully no one's going to disclose what they actually saw. But in the domain, there's 6 domains. I would encourage a learner to go through all of them and say, do I know this? Do I know this? If it says configure OSPF, I'd want to make sure I could configure OSPF and be able to do it. And then when they ask you a question, here's what I love. Let's imagine you're in testing and they ask you a question about which of these 5 IP addresses fit in this subnet or which route would be used. And you can say, yeah, I can figure this out. And you take the block size for the mask, you calculate the ranges, and then you say, oh, it's that guy. and you move forward as opposed to worrying about how they're going to word it. You can answer the question. And what else was I going to mention there? Oh, in the testing environment, this is important. Breathe. Just breathe. When you show up for that, I always drive to the exam early when I take an exam, whether it's for any vendor. I make sure I know where the testing center is, what time of day I'm going to go, make sure I can get there 15 minutes early, maybe 20. Sit in the parking lot. Just breathe. Your study has been done. You've prepared. Just breathe. And breathing is a really good technique just to make sure you can be on the best game you possibly. Sleep a little bit the night before, not a bad idea. I've been told not to cram the night before. I do. I cram. I'm always cramming. So I've got a lot of stuff on my plate these days. And so I believe that if a person does a nice, long study path, it's all gentle and everything else, great. But if there's a piece or two that you don't know at the end, it might be handy to take a look at that. Example from 2001, my first CCIE, which I passed on the first time. It was a 2-day exam. I'll make this quick. The whole video is up on YouTube if you want to check it out. But the first exam, it was a 2-day event. And again, I got to trim it down for this so I don't spend 20 minutes talking about it. It's a 2-day event. You go for the first day, and then when you come back the second day, if you got enough points the first day, they say, yeah, you can stay. If not, they tell you in that second morning, sorry, you didn't get enough points, you have to leave. And so that first day, I rushed through. I was doing the best I could, a lot of hiccups along the way. And then when I went in for the second day, I was able to continue. But before that second day, my alarm clock in the room This is when we used alarm clocks in 2001, before Siri and all those things. But my alarm clock, the clock was an hour off. I didn't realize that. And so I set it, and it went off an hour early, my advantage. And then I thought, you know what, I better study, I think it was IPX, SPX, network, average. Like 2 decades ago, IPS, the Novell protocol was on the exam, along with ATM and token ring switching and data link switching and all that other stuff. Anyway, so I studied. I said, I've got an extra hour. I'm gonna go and lab this up. So I had my computer. I was using, I don't know if I had GNS3 at the time or not. I think I logged into Live Gear is what I had to do. So I tunneled out, connected to some Live Gear, and I practiced with some IPX, SPX network statements. And sure enough, that day, when I was going to do it, I needed that knowledge. And I needed to do it quickly, so I didn't have time to why isn't this working? Why isn't it advertising? Is this network type not right for IPX? So anyway, long story short, I still cram a little bit. If I have an exam, I will prep. I will study. And then usually the night before, and sometimes the morning of, I would just review my notes just to get my brain going and remember those things that I'd studied, and then go in. I wouldn't study in the car when you get there. That's probably too much. But breathe. Get to the testing site. Take a nice deep breath, relax, and just think, I get to see the exam. I get to see the actual exam, which is kind of cool. And then crush it. And also, if you get a question that you're not comfortable with or not sure about, it's okay. It happens. Like, I remember seeing some questions like, I have to stop myself from chuckling. I have no idea what that answer is. I've never heard of that before. Or the case where I'm wondering, did the test writer know the behavior? Like if a layer 2 switch doesn't have a default gateway, what's it going to do? Does the test writer know it's going to do a ARP request for a non-local address if it's trying to respond? Questions that shouldn't be asked at the CCNA level, but those are some of the questions I ask myself, and I remember what test I'm taking and thinking, they want the straight answer. So here's what I've heard from people who've taken the YouTube videos I've seen. These tests are very, very fair. They are like the DevNet exam, very fair. They asked you in the blueprint to cover a certain number of things and learn those things, and that's what they tested on. Same thing for CCNA, very straight up and fair. Nothing like really weird. So that's great news. That's so Kenny, hopefully that helps a little bit. All right, in an MPLS branch office subnet, what would be the best approach for Vlsm if they have a firewall? So if usually a customer, if the service provider is using MPLS, we won't know it. Let me show you. And let's imagine this is us. This is our headquarters site. Let me bring my pen back. If we have a service provider and they're providing us MPLS services, they can provide us layer 2 services, or they can provide us layer 3 services. And with layer 2, we're basically peering back and forth with the headquarters office. And if they're offering layer 3 services, we'd be peering with the service provider. But either case, if they have MPLS here, I can spell it, MPLS, multi-protocol label switching, and they're doing layer 2 VPNs or layer 3 VPNs, it's transparent to us. We don't know. All we're doing is we're peering with the routing protocol like OSPF with them, and then they're taking our routes along with their 50 other or 500 other customers. And what they're doing is they're making sure that our traffic gets, our routing information gets propagated between our 2 sites, and their other customers, their routing traffic gets propagated to their respective sites. So normally, the branch office, it wouldn't be label switching. We'd just be running a routing protocol, either peering with headquarters or peering with the provider. At the provider, that would be called a provider edge, but we wouldn't actually do MPLS ourselves as we interfaced with that service provider either way. So good question. Next question is, Learn IT is saying, by the way, the chart was great. Thank you very much. I was looking for the optimal way to get that done. I appreciate that feedback. I will continue to follow that mode. All right. And there's a question from Alan about CBT nuggets and content there. I will address that separately. We're working on Encore and other courses at CBT Nuggets where I work full-time at the CCNP level. CCNA is already done. It's like 52 hours of training. Really good. Jeremy Chara, myself, Network Chuck, great stuff. And then for Encore, which is at the professional level, we've got same people plus Jeff Kish and Knox Hutchinson. So we have 5 trainers that are doing various parts of that. I don't know when it's going to be about. I'm hoping for April. My part's on track, so wish us the best. It's going to be amazing. It is amazing. The stuff that we've seen already, it's great stuff. All right. All right, Adolf, thank you for that. And Angelo, the push flag on TCP. If you would, Angelo, for that question, would you, if you put that in a recommendation in the Discord server, that'd be awesome. I don't want to lose that. I'd like to take that idea if enough people want it and create a short stream or a video on it. And as far as a CCNA course online, my full gig these days is CBT Nuggets. I love it. They treat me great. I have a lot of autonomy. I'm working with a great team. I'm loving everything there. So as far as creating a separate course, these live streams and other content that's on on YouTube, I'm making it primarily to be free. At the moment, I'm not monetizing anything, so it's all just free and just for people to help reinforce what they're learning and learn new things. And this is close to what I'll make as far as an online course is the YouTube channel here, which isn't going to be a complete course, everything you'd ever need to know, because I probably won't go into the weeds regarding cable types and fiber connectors and other things that are covered in the full CCNA course, but I want to cover those things which I feel are really important regarding skills that are important to know and understand. So thanks for the question. All right. Overproof 876 is asking, I mentioned pursuing the CCNA CyberOps. Should I wait for the new Cisco Certified CyberOps Associate exam? That's a great question. So Cisco was going to tear down all their CCNAs, and then what was left up there was the CyberOps, but they're calling it the CyberOps Associate, so they can still say, yeah, we pulled down all of our CCNAs. I need to look in to see if the exams are different. So in the past, CCNA CyberOps was 2 exams, Security Fundamentals and Security Operations, and that would get you your CCNA CyberOps, but now they're calling it the CyberOps Associate. I have not looked into whether or not they have a new exam for it or if they have the same old 2 exams. So that's something that you could just take a look, go to cisco.com, career certifications, CyberOps Associate, and then take a look at the exams. If they're still asking for the CyberOps Fundamentals, if they're still looking for the Fundamentals and the Operations exams, those 2, it's the same 2 exams that have been out, so there wouldn't be a reason to wait. But that's a great question. I had not heard that they are going to be updating those exams because that is a fairly new certification as it is. So I will look into that as well. All right, thanks for the questions, everybody. I don't know if you could hear that squeak. It squeaked. It squeaked. All right. Nason, are the wasted IPs that could support a subnet potentially a security concern for a network? I mean, like a rogue device behind a firewall. And that's a great question. If we have a subnet that supports 248.16.32, let's say we're using 5 host bits and we can support 30 hosts, but only 20 of them or 25 of them are needed. We have some other addresses that somebody could insert, like say a Raspberry Pi. This would be an internal deal because they have to get to your network. So you could have an employee or somebody on the inside who's physically connecting to the network if it's wired to get in, and they could use an additional IP address. But the reality is that if we need 20 IP addresses, we wouldn't want to, or if we have 30 devices, we probably wouldn't want to have just 30 available IP addresses because there's going to be something that comes in like tomorrow that's going to need an IP address. We'd want to give ourselves a little wiggle room. So that wiggle room, the extra space, doesn't really cause a security concern. Here's what would be a security concern, easy for me to say, is that if we had, in TCP, there's something called a 3-way handshake, which many of you are probably familiar with. It goes something like, hey, here's a synchronization request. In the TCP header, it says the SYN request. I'd like to talk with you. And the other party says, sure, I'll talk with you. It sends an ACK back, an acknowledgement, and it sends its own sequence with it. So they call it a SYN-ACK, although it's really like an ACK-SYN, because the acknowledgement and then the SYN in the same packet. And then the third follow-up is the final acknowledgement. So SYN, SYN-ACK, ACK. And then, boom, we know we're talking. And then, what do you want to talk about? And then they go on to establish a formal session with an HTTP server or SSH or whatever they're communicating with. So a hacker or an attack tool can often do scans of the network, and there's multiple ways of doing scans. To discover on the network, we can send ping packets out to the whole subnet. So, are you home? Are you home? Using ICMP, are you home? Are you home? Are you home? And then the attacker says who responded. Now, a firewall and other devices on the network may not respond to a ping. In fact, Windows Firewall, I believe in its default condition, won't respond to a ping. They don't want to let anybody know they're there, which is a good security measure. But that's one way. So if the ping doesn't work because people are not responding to pings, we could do a TCP SYN request, and we could send it to every IP address on the network. And then if a device is listening on a given port, it could respond, or it might send a message back saying, I'm not open on that port, which means, hey, if you're not open on that port, that means that, I know you're there. Or check this out. In preparation for all of that, if we're doing ARP requests to everywhere on our network as part of a follow-up ICMP message or a follow-up TCP three-way handshake attempt as a scan, if we do an ARP request and somebody responds, we know they're there. Either that device is there because they responded to our ARP request at layer, for resolving the layer 2 address, or we had proxy ARP involved and some other device was responding on its behalf. But either way, we know that somebody responded, and that's another way to start mapping the network. So long story short, too late for that. If we were doing analysis of our network and we saw that we had 5 subnets, let's say 10.1, 10.2, 10.3, 10.4, 10.5, but we did not have subnet 10.6, or we didn't have a subnet, like a custom subnet, that was used in our variable length subnet masking. If we saw scans or attempted connections to that address space, the whole subnet, where we don't have any devices, red flags, because somebody is looking where they shouldn't be looking, and they're trying to find addresses in that space, and there's no address space there, including non-direct. If we're doing requests over networks, looking for certain devices, that would raise a red flag. We shouldn't have anybody resolving a name to an IP address that's in a subnet that we don't use, and we shouldn't have people sending packets to a subnet that we don't use. And so it's very likely malicious, and we would track that down with our tools and say, okay, someone is not someone. We could identify the MAC address involved, even if it's spoofed. We could identify the source where it came from as somebody's trying to do a mapping of our network. So getting back to the question, if we have 30 available host address spaces, and we're only using 20 in a certain subnet, that doesn't really pose a security risk by itself. It's just a few additional addresses that are available on that subnet. All right. And I think that's a confirmation. Let me take a look at the next one. Raging Crypto is asking, can you go over the route summary on those networks? And those networks, I'm not sure exactly. Let me give you an example of a gross over summary. A gross anything is too much, right? Oh, that's a gross abuse of, your permissions or privileges, or that's a gross abuse of your role. Here's a gross summary, and it goes something like this. And we'll have a separate section on just subnet on summarization. Let's imagine that headquarters, and I will bring a pen up. Let's imagine that headquarters, instead of having to learn all these routes, which is 1, 2, 3, 4, 5, 6, 7 routes, instead of having to learn those 7 routes, which aren't that many, but if we wanted to reduce the number of routes we'd have to learn, we could go ahead and have a summary route at the headquarter location that said this. To get to 10 anything, go ahead and forward it to your next hop route of their R3. Now, the reason that's a gross over summarization is because, we're summarizing with one route, a 10 anything, that all these routes, these subnets can be reached. But what about 10.1.0.0 and 10.2.0.0? And we just play that game for like 11 billion years. There's a whole bunch of other networks that's summarizing that it covers, which is way beyond just this network. So a perfect summary would be this. If corporate asked us to use this address space, we could have one route. And on the route, it would say IP route to get to 1067A3.0/24, send it to R3. That is actually a perfect summary for all of these networks, because all these networks fit underneath that address space. And so corporate could have specific summary routes like this for all of their branch offices, and from a hierarchical perspective, we could create additional summarizations so that we can reduce the routing tables. And also, let me share with you the ultimate summarization. On R3, let's imagine R3 has the connection to headquarters, and that's also the access for the internet for everything else. On R3, here's the ultimate summarization. Let me get rid of my face there. It is 0.0.0.0, which is the default route. And the next hop would be HQ. And so what that does, that simply says, okay, everything that's not in my routing table, says R3. Everything that's not my routing table, I'm going to go ahead and send over to HQ and let them take care of it. And if this is a stub, meaning an area where, not a stub, but a portion of the network where it has no other access to the internet or anything else except right here through R3, that's a perfect way to go. And so this default route effectively is a summary for everything that is not local here on this network. All right, thanks for that question. And that was from Raging Crypto. Thanks, Raging Crypto. I don't know if you hear that. It's fun noise. All right. Dimitri was asking why you say that the test has a bug. What do you mean by that? If you could repost that, rephrase it just a little bit to make sure that I understand where the question was tied to. I'm not sure what that's a follow-up to, but I would love to. Okay, let's see if there's any other questions for me. Scrolling down, I've got another question from Daniel. Does class affect variable length subnet masking, like a class A or a class B or a class C network? And no, it doesn't. So as long as you have routing protocols, which is pretty much everything except RIP version 1 that supports variable length subnet masking, you're good to go. So in our network here, we did a 1067.83.0 with a 24-bit mask as the parent network. That's already subnetted officially, because a 10 network officially is a class A address. So the first octet is the network. The last 3 octets are the actual host address by default. And so we've already custom subnetted it. But the subnetting process works exactly the same. You take where you're starting and you start making the mask longer, leaving enough host bits available, and keep working through it. Great question. All right, Fat Justice, thank you for the super chat. Also, Alan, thank you very much. The super chats are nice. Thank you very much. Not required, not expected. I appreciate everybody being here and your time and volunteering on the channel to help other people. So Fat Justice and Alan Bandwi, thank you very much. All right, another question from Darshan. Okay. It's more of a statement rather than a question, so I'll go on to the next one. Another question is asking, I saw something the other day. A PC had 2 different IP addresses on separate IP blocks using a single NIC. So just guessing, if there's a computer that has 2 different IP addresses, a Cisco router can do that with what's known as a secondary IP address. So it's one physical interface, but it has 2 IP addresses and 2 different subnets, and that's usually to support 2 different networks in the same VLAN. So life isn't always pretty in the world of IP networking. So if you have one VLAN, one layer 2 broadcast domain, and you're migrating, or you ran out of room, let's imagine that you had 30 hosts available, and you find out, oh my goodness, we need 60. You could put a secondary address in the next subnet on that same interface, and then that one VLAN logically have 2 layer 3 network address spaces. And then they would each have their own default gateway on the appropriate subnet logically, and it's not pretty. If you look at a service provider network though, like cable modem, and you do start to do packet analysis on cable modem and you're directly connected to their network, you're going to see IP addresses from lots and lots of different subnets. Like, how'd that happen? Those packets aren't on the same subnet? I know. What they've got is they've got large VLANs. In the case of cable modem, they've got their own technology for doing it. But when there's the layer 2 broadcast domain that you're connected to with all your neighbors and probably their neighbors and their neighbors, it's very likely supporting more than just one IP subnetwork. But to be clean and have nice, accurate networking, we generally want one VLAN, one subnet, and then not have to play any tricks. And as soon as I say that, I realize that we have to play tricks sometimes to make things work. Like when Paramount Pictures bought Viacom, like 2.5 decades ago or whatever it was, we had to play tricks. We had to lie to both sides with NAT to get connectivity, and we had to migrate. And so those are all real things in the production environment that have to happen from time to time. So thank you for the question, Dino. All right, let's see if there's anything else. And Paul, you're very welcome. Paul Fischetti, it's great to have you. Appreciate that. Angela's asking, Great question. Angela is asking, why do you not consider the network between the two routers, the core switch? Let me just bring up the topology, and let's talk about that for a moment. So on this device here, if this core switch, if this is an access port in VLAN 10, and this is an access port in VLAN 10, it is one network between R1 and R2. So that could be like the 10.0.12 network or whatever it is between them. If the core switch is participating in routing, it could have a VLAN interface for VLAN 10, and that VLAN interface could be, maybe this is .1 over here, .2 over here, and maybe the core switch on its VLAN interface, that's the layer 3 switched virtual interface VLAN 10 could have 10.0.12. Let's call it 3. So now we have 3 devices on that same network. On the other hand, if we chose to go ahead and make this interface here on core 1 a layer 3 interface, the physical interface, and we chose to make this interface here a layer 3 interface, then we would have network, I'll say network X and network Y, because they would be 2 logical separate networks if these were layer 3 interfaces. The other option is also, here's one more option, and you guys are good for this, so let's go ahead and do it. The other option would be, let me back off some of that. Almost there. Yay, I just hit my buffer limit. So if this is VLAN 20 on this port, and this is VLAN 30 on this port as access ports, then R1 and R2 would be in different VLANs. They wouldn't be neighbors. And then core 1 could have interface VLAN 20 and peer with R1, and R2 are then core 1 could have interface VLAN 30 and it could peer with R2. And if we did that, then it would look like this. R1 right there. Let me bring my face up here. So it'd be R1, core 1, and then R2. So logically, these would look like routers if we did that by simply putting in different VLANs. So this is VLAN 20, this is VLAN 30, and the core switch has logical SVIs in each of those VLANs, and it would just be like another router in the path. So there's like 3 ways to carve that up. We just talked about all 3. And that answers your question, I believe, which was, why isn't there an additional network between R1 and R2? It's just depending on how it's configured. So that's a fantastic question. I love it. I still remember my first trainer that I learned multi-layer switching from, Johnny Bass. He's still around. I still see him at Cisco Live every year. I make it a point to go say hi. He teaches at Cisco Live. Great guy. It was when we had separate, I'll save you the history lesson. But it was amazing to me. I was like, oh, I get it. These switched virtual interfaces just pop in. And back in those days, we had route switch modules with logical layer 3 interfaces. But it's good stuff. It's good to know how it really works. And then it's like Tinker Toys. You put them together in any way that you want. So if you had a topology you needed to build or modify, if you know your options, layer 3 interfaces on a multi-layer switch or switch virtual interfaces, it's fun. It's a lot of fun. And let me take a look at the next question. All right, another question is from Bhaskar. Is asking, what is out-of-band management? OOB, O-O-B. Great question. And let's look at the topology and talk about that for a moment. It's really important. And let's do this. Let's imagine that HQ, on a good day, wants to be able to manage all these devices. And so they've got a management computer, and they've got a terminal emulator. We'll just go old school on this. They've got a terminal emulator, and they can connect to this PC, to this router, and all the routers, and the multi-layer switches, and the access layer switches. And that's because on the access layer switches, they have an IP address in that subnet, and they have a default gateway that teaches them how to reply back to HQ. So HQ's happy. They can manage all of these devices. And what that's called is that is referred to as in-band management, meaning we are using the data plane, the packet flow from the management computer to communicate and work with all the devices. In-band management. So what happens if we lose the Mpls network? It just goes down. It's gone. And then the HQ says, well, how do we manage those devices? And then somebody says, boy, we should have planned for some out-of-band management, meaning an alternate path, not the primary data plane that everybody else is using, some alternate path to go ahead and manage those devices. So one option is we get a server that we could put in the wiring closet at that remote location, or perhaps in the, if it has a small, it won't have a data center at the small location, but where we keep the gear, like the routers and stuff, in that same air-conditioned and monitored room, we could have a server that maybe is connected out through the PSTN, which is the public switch telephone network, old school. Or maybe we have this device with internet connectivity through DSL or cable modem, but it's some other method that's not going through the service provider Mpls network. So if they go down, then headquarters can go ahead and connect to this box right here, this terminal server, and then that terminal server can either have console access or IP access to those other devices. And to keep it really out of band, we might want to make one. So let's say we use VLAN 25. We create VLAN 25, and we use VLAN 25 just for management. So we have a separate VLAN just for management. We have a separate box that's using methods other than the MPLS network, the service provider network, to go ahead and get there, so that we have out-of-band management. It's really important, by the way. So I appreciate that question, the opportunity to chat about it, because there's nothing more frustrating than losing your connectivity to the network that you manage. My first experience with that, and I've had many, some were my fault, some weren't. But my first experience was like in 1986, 1987, and it's in my memory because I know when it happened, I thought, oh, I just did that to myself. What I was going to do, and so out-of-band management is a great idea, and the only way to test it is to actually test it, make sure it works. So I was doing some update to like 7 devices on the topology. It was in Woodland Hills, California. I lived in Simi Valley, which was about, 20, 30 minutes away. And my plan was to connect to the edge of the network. In those days, it was modems, best option I had, and a modular old school modem. So I was connecting to the edge device, and then I was from there going to connect to the furthest device, make a configuration change, reboot it, and then go to the next. I had like 7 devices to configure. And I was going to work my way back to the device that I was connected to initially, and then my last step would be make the changes there. Well, in my haste as a young person in those days, that was 1985 or 6, I connected, and I was so excited about getting going, I forgot which device I was on. And I made the configuration change on the edge device first, and when I pressed enter, my screen no longer responded. It's like, so the change I made was on the edge device. It didn't go well, and as a result, I had no further access to the rest of the network. No other out-of-band methods for managing it. So I don't recall whether I had to drive in that night or I waited. Yeah, I think we resolved it that night because production started the next morning. And anyway, it was a good lesson to learn. Oh, sorry about the camera move there. And so out-of-band management is a great idea. Not free, but definitely worth it and want to test. All right, so Demetrio, I apologize. I don't understand your question still, but if you want to post that in one of the forums on the Discord server, I would be more than happy to have the team, the community, look at that and make sure we get your question answered. My apologies for not knowing what that question is at the moment. And let's see, follow up on a question. This is from Dino. On a VLAN. On a VLAN that supports 2 different broadcast domains. Yeah, so let's talk about that for a moment. So a VLAN really doesn't support 2 different broadcast domains. Between friends, it doesn't do it. It's one broadcast domain. So whatever logical layer 3 networks we want to pile on top of that one broadcast domain, a broadcast from any of those networks, any device in any of those logical layer 3 network address spaces that we put into that VLAN, those are going to be seen by every other device in that same VLAN. But I get it. I get what you're saying. So if we have one VLAN and 2 subnets, is there any performance impact or repercussions? Thank you. Yes, there are. If you have, let's say you have 500 devices in one layer 2 broadcast domain. So you have 250 from subnet A, 250 from subnet B, and they're all sitting in one broadcast domain. You're back to a position where you have one broadcast from one device, like yelling in a room with 499 other people there. Hey, Bob, I'm looking for your layer 2 address. everybody, I mean everybody who's on that network has to say, what? Broadcast? This may be interesting. And so they because the layer 2 address is the broadcast, then they open it up. They see it's an ARP request. Then they open up the ARP request. They say, oh, you're looking for Bob's address, not me, and they discard it. Well, if we have 500 devices and we're ARPing, and that happens quite a bit, and we have other broadcast traffic too besides ARP, there's a huge impact on the other devices. So you want to keep your broadcast domains reasonably small, hopefully less than 200. Also for security reasons, if you have an attacker and he's got access to 500 devices on that one broadcast domain, and then he does a MAC off or a MAC flooding on the switch, so the switch forgets where devices live, starts flooding all frames to all ports, that's going to cause problems. And more for security, the attacker can then eavesdrop on all that traffic, which is not desirable. Okay. Let me see if I can pick up where I left off. See if there's any other questions. All right, MH Tech in the UK. Glad you're here. In fact, I'm so glad everyone's here. All right. One other question is asking, is there only one layer 1, layer 2, and layer 3, not layer 4? I hear about the layer 1, 2, 3 all the time, but I don't know. That's a great question. And that probably, I'll tell you what, for that question, for a better understanding of that, check out the playlist, the CCNA playlist. The first 2 or 3 videos will cover that. But effectively, logically, there are 5 functioning layers in the TCP/IP protocol stack, and it goes something like this. You have a customer, a user with a computer that understands TCP/IP, and they send a request. Now, in that request, they're going to be leveraging the application layer, usually, like a web service. So that Bob's looking to go to a website in his packet at the application layer, it's going to be making an HTTP request. HTTP is an acronym, it stands for Hypertext Transfer Protocol. It's basically the language of love for a web server and a web client to talk to each other. And then at layer 4, that's the application layer. So we don't call it layer 5, we just call it the application layer. And then below that, we have something called the transport layer. And that's based on the type of protocol used. It's able to, like TCP, can set up a reliable connection-oriented protocol or conversation. So TCP, Transmission Control Protocol, is a layer 4 protocol. UDP, User Datagram Protocol, doesn't really care about keeping track of its neighbors and keeping track of the session, but it is also another layer 4 protocol. There's also others like GRE, Generic Router Encapsulation, and IPsec, ESP is there as well. So there's other protocols at layer 4. And then at layer 3, that's IP headers. IP routing is done at layer 3 based on IP addresses, and then layer 2 on Ethernet is done with layer 2 MAC address headers, not referring to Apple products, but rather immediate access control headers. Layer 2 addresses, physical addresses, hardware addresses, and switches make forwarding decisions there. And then the bottom one is physical, which is referring to the bits and the signals of that data actually being moved on the network. So check out that playlist. I think that'll help a lot, especially in the first 2 or 3 videos in the series for the CCNA playlist, the master playlist. It'll help with those as well. And the reason it matters too is because as we start looking at securing our networks and we're using application layer firewalls, what they mean is you have a firewall that can actually look at the upper layers and see what's going on. So is this a Facebook just looking at the web page, or is this a Facebook instant messenger, or is this a Facebook file transfer? And application-aware firewalls will know details about what's going on so they can control that traffic at the application layer. Yep, I've been there, Daniel. Thank you for that. And Demetrio, glad to have you here. Australia's in the house. And the link for Discord, I tell you what, I can't find the link for Discord. What I'll do is I will put it on this video. In fact, let me just grab it. Let me just grab it right now. I've got it in a Word document, so I can just bring up that Word document and we'll have it here in a second. Meanwhile, just talk amongst yourselves. Let me clear off my screen. There we go. Not so hard. Copy. I can use the mouse. And I'll go over here. And I'll do a Control V. And boom. There you go. Thanks for your patience. Love to have everybody in Discord who wants to be there. There's a rules section. Just check out the rules. Make sure you're comfortable with the rules, which basically say be a nice person, help other people. Don't share anything that is commercial or paid. We're not giving away people's hard-earned content. This YouTube channel is totally free. But if you have like a PDF or other content from other vendors who is paid for, please don't share anything like that. Also, no brain dumps, no sharing or breaking the disclosure agreement with Cisco or anybody else regarding what you share. And also protect your personal information. So here's the scoop on that. Many of you may want to connect and do study groups and things like that, but be very careful about publicly sharing any personally identifiable information. That would include phone numbers, personal emails, anything that might be really enticing for an attacker to compromise your security. So to do that, you could exchange emails privately if you wanted, and then you could email each other and do it that way. But it's a good idea to be very concerned and careful with your personally identifiable information. The hackers are getting better and better all the time. Once I used to work, this is safe. I used to have a top secret clearance. Don't anymore. That was many years ago. And the Office of Business Management, OMB. Anyway, they got compromised. There's millions of records that were stolen, including background checks for a lot of people who had top secret clearances, or hundreds of thousands of people. So there's a lot of information there, like everything. Who was your best friend in high school? And they gave us some credit monitoring tools for free for the rest of our lives, for us and our families, that we could keep very close track on whenever anything is looked up or revealed or on the dark web that comes up regarding our email addresses, our phone numbers, and so forth. I'm grateful for that. I'm not grateful that the data got stolen, but I'm grateful for the protections they've given me after the fact. So one day I got an alert that said, on the dark web, here's what was stolen. They tell you exactly what was received or transferred or gotten. And it was a mailing address for a house that I don't live at anymore. So it was a little bit old. And so it was my name and my mailing address, which was a house address. And so a day later, somebody shows up. I'm not at that house anymore, but there's a person at that house, and they came asking for Keith Barker. Yeah, I'm looking for Keith Barker. I've got not a subpoena. What do you call it when they want to have you show up in court? Maybe a subpoena. I've got a subpoena and a check for him. And the person who knows me at that property said, yeah, he doesn't live here. Hard stop. Don't reveal anything. And then that person called me and said, yeah, they were looking for you. And I said, yeah, that information was just leaked on the web, maybe like a really short period earlier. And so I knew it was a scam. It was if somebody's looking for me, they can find me. I'm in official places. I'm not hard to find. Like, go to Keith Barker Networking. I might be here. So anyway, the hackers are getting better and better. I don't know where that would have led to, whether it was a scare tactic with the IRS is coming, and if you need to settle right now, or what the check thing was about. I think it was just to have her accept it, or for them to take one step further. But if it sounds too fishy or too good to be true, either way, it probably is. All right. So manage your personal information carefully. And Dina's asking, are out-of-band management ports on the control plane? So out-of-band management is just more of an idea than actually a port. So the control plane is how devices learn about stuff. Like how do 5 routers know how to route? Well, they need to be trained on how to forward. We could do it with static routes, or we could run a dynamic routing protocol like OSPF, and they can dynamically teach each other. And that is the control plane. Them learning about how to forward using a dynamic protocol as an example is an example of the control plane. Us managing those devices is an example of the management plane. And it's on that management plane where we have access to our devices and can communicate with them that we want to have the out-of-band, which is referring to out-of-band management, so that we can still manage those devices even if our primary networks go down. And that's also true for software-defined networking. We want our controllers to be able to talk to those devices in the event that we have a failure somewhere in the network. We don't want to lose complete access to those devices from a management perspective. So it's not going to be a specific port. Out-of-band management is more of an idea, and it can be implemented several different ways. All right, Daniel, thank you for that. And Gabriel's starting a new job next week, mostly layer 2 and layer 3. Can you recommend any reads or other documentation? What I love about, especially if it's the first job in the field and getting in, is that you're going to learn. Most people get hired because of a basic awareness of how the network works or what the technology is, and then when you get in is your real opportunity to become a master. So I would ask the person that hired you is there anything that I can do now that would help prepare me for when I start next week? If you've got the job already, just say, hey, I'm ramping up, just going to get dialed in. Is there anything specific I can start studying or looking at now that can help me hit the ground running when I start? And be sincere. And then if they give you a recommendation, do it. I did the same thing with EDS back in the early 80s, electronic data systems. I was interviewing and I said, what can I do now to help me prepare to be actually hired for the job? I didn't get the job yet. I was right out of school. And they said, it was Anita Martinez. And she said, yeah, well, HP laser jets are kind of a new thing. Here's the manual if you want to start studying on those. And I did. I took it home, started reading. Corona wires, fuser assemblies, the voltages, the positive, negative charges. Still remember all that stuff because I dug in. And then when I met with her for my final interview before they made the hiring decision, she asked me, so tell me what you know about, HP laser jet printers. And I did. And she goes, okay, yeah, it's good. And I think I got the job because I was willing to do that. So once you get that first job, the secret is whatever technology they have, how can I provide more value? How can I provide more value for this company? If knowing this, would that make me more valuable? If it's something cool that you just want to learn, do it on your own. Like, I want to learn how to build a drone. Great. Do that on your own. Or I want to do Raspberry Pi development and build Raspberry Pis and make robots and hacking things. Do that on your own. But look for what they have and how you could improve and provide more value to that company. Because the secret is when you start learning something more and studying it, if you can apply it, oh, that's the juice right there. It's because you can then apply it. It's like ASAs. I haven't touched an ASA in a while. I've been working with the Firepower Threat Defense System more recently. But if I had to go back to an older ASA like version 9 or something, I could do it. Only because I've had lots of practice on it, because there was a need where I was, and I just started working with it. And that's what I would encourage you to do. So start to become a master on whatever they would like you to do. Do more than you're paid for. And I'm not talking about work 14-hour days if they're only asking for 12. That's only a slight joke. But do more than you're paid for. Jump in with enthusiasm, being willing to learn. Spend your own time in getting better and better. And what you may discover is that it's going to be hard for a company to keep you more than a year or two because your skills grow. As your skills grow, your value increases to a point where you might be really worth a lot more elsewhere. And sometimes it just, they've got a budget for X and that's what they want. So always do the right thing, be ethical, and just keep on climbing. IT is a great, great option. Okay, I ranted on that. Let's see here. Oh, that link doesn't work. Michael Taylor saying that link doesn't work. Let me try it right here real quick. Yeah. It's working for me. So, let me verify that works from a couple different places. And if you have a proxy server or something else that's filtering traffic, that might cause it to stop. But I will double check on that for you. Thank you. And I'll post notes if I find a problem with it. I'll post that with this video. Oh, okay. Michael, I should have read your second comment. Sorry about that. It's working. Great. All right. What is the difference between a static and default route? Raging Crypto, that's a fantastic question. What is the difference between a static and a default route? Let me show you. Let's start off with a default route. This is a great question. That's why I'm happy to, and it's right in the world of CCNA, so that's why I'm happy to do it. Let me clear that. And let's imagine that R3 is the connection. Let me get rid of this too. All right, that'll be better. So let's imagine R3 is the router that has access to the rest of the world. So the internet is a big place. We'll call that, label it I. And we're running a routing protocol in our organization. Maybe we're running OSPF. So we go to each router and we type in router space, OSPF space, process ID. It gets a router ID based on the highest, if we configure a router ID, it takes that. Or if there's no router ID hard-coded, it takes the highest IP address on the loopback interface. If you don't have a loopback interface, it takes the highest IP address on any other interface. And if there is no IP address anywhere, OSPF says, no. It does. It says, I can't identify a router ID, so you're going to have to just park right here until you get an IP address somewhere, configured or an interface. So once we enable OSPF, we then go ahead and do network statements. We've covered that in previous sessions. So every router here knows how to reach every one of our subnets in this space. So far, so good. And then we decide, well, I'll put Bob here. Bob may want to go to the internet. Maybe he wants to go to his favorite website. Let's put fave. www.fave.com. That's his favorite site. Now, if that's a real domain, it's an accident. So Bob wants to go to fave.com, and when router 4 receives that packet, well, let's actually talk about the truth of what really has to happen for that to really work, because we're in a little chat mode here, you and I having a conversation. So let's look at all the pieces, and it won't take that long. And some of this may be a good reinforcement. So Bob's computer, at Bob sits down and types in www. Oh, that's on my face. Ouch. It's on my face. All right. Bob types in www.fave.com. And then what does Bob do next after he types in www.fave.com? He uses his favorite browser. Maybe it's Safari or Chrome or Internet Explorer or Edge or Firefox or whatever it is. So he types that in and then he presses enter. That's what I was going for. He presses enter. And behind the scenes, his browser assumes that he is going to go to a web server. Let's imagine that this is the web server. So in the layers that were asked about earlier, there's the application layer. So when we think of layers, just think of a logical process that has to be gone through. I mean, if you had to surgically slice and dice, it'd be very tough to find application layer but protocols, services run at the application layer. And one of those services is called HTTP. And HTTP is the language of love. It's like the program that's used between Bob's computer and the web server. And so Bob's computer, when Bob presses enter, is going to format an HTTP request that says, I'd love to see a web page from you. But before that happens, that's the app layer. Before that happens, it's going to go through some other logical processes. And one of those is at layer 4, and it's going to use TCP. So TCP, Transmission Control Protocol, is the layer 4 protocol that cares. It's the one that does the, how you doing? It's sort of like going to a grocery store and making small talk before you start talking with somebody. TCP says synac, ac, hey, we're talking. What do you want to do? So TCP is used by HTTP. Now, we don't get to choose that. We don't get to say, I want to go to a web page, but I don't want to use TCP. It's baked into the application layer protocol. So if we're using HTTP, so if Bob's using a browser and Bob's going to this website, Bob's computer is using HTTP or possibly HTTPS for security, and below it at layer 4 TCP. Then as that information continues down to the wire, let's say this represents the actual network that Bob is sending on, there's going to be layer 3 information that's added. And that layer 3 information, this is the network layer. Oh, I should be consistent here. Let me be consistent. So layer 4 is the transport layer, and layer 3 is the network layer. And at layer 3, we're using IP, and to be specific, version 4. Not version 6. Usually, 10 years ago, they said IPv6 is coming. IPv6 has been out for so long, and it's still not the major protocol that we use on the internet today. IP version 4 is, which is what we've been talking about exclusively in our Subnet Saturdays. So at layer 3, Bob's computer is going to use his own IP address as the source address. I'll put that right here. So, and I'm going to line this up so it lines up with this guy right here. So the source address is going to be Bob's computer. So Bob is sitting here at 10. What is his address? 10.0.4.10. That's his address. Just let's pretend it is. And he's got a 24-bit mask. So in his source address, he's going to say, I'm at 10.0.4.10. And the destination address is going to be something. It's going to be the address of the server. Now, behind the scenes, Bob's computer has to figure out what the heck is the IP address for www.fave.com. And as a result, we have to do a little segue. Because behind the scenes, Bob's computer says, I don't know that already. I haven't learned that yet. I need to know what www.fave.com is, what that IP address is. So as a side story, which I'll put in pink here, it makes a DNS request, Bob's computer does, DNS at the transport layer uses UDP and has specific ports assigned to it. And then what Bob's going to do is Bob's going to send an IP packet sourced from Bob and destined to the DNS server. So as part of the configuration on Bob's computer, something had to tell Bob who the DNS server is. DNS stands for DNS Domain Name System. It's how we figure out what the IP address is behind an IP address. And that could have been learned by Bob's computer via DHCP, or it can be statically configured. But either way, Bob is making this little interim step to make a request, an IP packet, to that DNS server. So let's say the DNS server is over here. And let's say it's 10.0.2.44. So that's the IP address of the DNS server. So the destination address would be the DNS server. And then at layer 2, I'll go back to black here. Bob, for the DNS request, is going to use the source MAC address that's built into this computer. So Bob's source MAC is at layer 2. And the destination layer 2 address is going to be Bob's default gateway. And that's because Bob said, I'm on 10.04. My DNS server is on 10.02. Different network. And so I'm going to go ahead and use my default gateway's layer 2 address. And at layer 2, it's going to have the source MAC address of Bob. And the destination, oh, I should use pink for that. Let me keep that consistent color for this little side conversation that he's having. So at layer 2, the source layer 2 MAC address is going to be Bob. And the destination layer 2 MAC address is going to be R4 gig 0/0. And then at the physical layer, which is also called layer 1, and layer 2 is also often referred to as the data link layer. So Bob's computer is going to send those bits on the network. The switch is going to forward it to the right layer 2 off the right port, the access port. Router 4 is going to make a routing decision up to the DNS server. R2 is going to help with that process. And then the DNS server is going to get the request, www.fave.com. It may have to go out on its own to figure it out, but it's going to get the answer eventually, send it back down, back to Bob, the client, and now he knows the IP address. It's like, what? All that just to learn the layer 2, the IP address of fave.com? Yes. And Bob's going to cache that for future use. So in the future, if he needs to go to fave.com, he'll know what that address is. And so now that I've introduced the DNS piece, it's done. And we can go back to his conversation between Bob and his favorite web server, now that he knows the layer 2 address. Okay, so on our road trip here, now Bob knows the layer 2 address of fave.com. We'll say it's 23.67.83.100, just for grins. And it's a globally routable address on the internet. And so at layer 3, for the IP header, the source address is going to be Bob at 10.04.10. And the destination is going to be 23.67.83.100. And then so this is layer 3. Then at layer 2, Bob is going to say, whoa, this network is different than my network. And actually, the truth is, Bob has no clue about the destination mask. All it's doing, Bob is saying, well, I'm on 10.04, and my first 3 octets don't match the first 3 octets of where I'm going, so it must be a different network, even though we have no clue what the remote masks are. All we know is that what our mask is, what we believe the street is, and then we're going to forward to a default gateway if we need to get off our local subnet. So at layer 2, it'd be Bob's layer 2 MAC address for the source, and for the destination, it would be R4 again. R4 is gig 00. Just like that. And then the bits would be spit, and the bits would be spit out. The switch would look at the layer 2 destination address, make a forwarding decision layer 2 over to R4, who would see it and say, oh, this isn't for me. It's for 23.67.83.100, but I have a route. And that is where we can come in with the idea of a default route. In OSPF, what we could do is go to R3, and we've covered this in a previous session. And on R3, we could say default information originate always. And that way R3 is advertising to everybody here that there's a default route. And so R4 would say, I don't have a specific route for this network, but I have a default route. And let's imagine the default route is going this way, and R2 is forwarding this way, and R1 has a default route forwarding this way, and then R3 gets it, and then hopefully R3 has a default route going out. And that leads me to your question. It's like, what? This is all based on the question about default route and static route. This default route right here on R3, it could be learned statically, like this. Static. Static. That's inside my brain. Nobody should see that. IP route with spaces here. The Obi-Wan Kenobi route, which is that. That means nothing has to match. And then the next hop address. Oh, I forgot what it was. I'll put HQ IP. Whatever the headquarters IP address is off this link, or whatever our service provider is, whoever that next hop is, we create that static route. And that is an example of a static route because it's statically configured, and a default route. It's a statically configured default route. And R4 and R2 and R1, we didn't have to statically configure it there because we told R3 to advertise that via OSPF. So on R1, 2, and R3, R1, R2, and R4, they learned the default route dynamically. So on them, it wouldn't be a static default route. It would be a OSPF learned route if we're using OSPF. And so these guys forward it, and then there's another little trick here at R3. If we send out a source IP address of this guy right here, our service providers are not going to let it through. Because it's a private address from the RFC 1918 address space. It's private. We can't use that on the internet. It's not routable on the internet. Not because you couldn't route it, it's because they won't route it. Service providers do not allow private address spaces to hit the literal internet. I mean, they may be sharing with us and stuff for their own purposes, but the real internet does not allow the RFC 1918 private addresses. So at this point, what we'd also do is a little game called NAT, or its cousin called PAT, which we have a separate stream on. And with NAT or PAT, we would take this source address, swap it out temporarily to a routable address on the internet. This R3 would remember that translation. The packet would then go to fave.com. The reply would come back to that NATed address. R3 would untranslate that and then route the packet back to Bob, who would then open it and say, yeah, great, web page. Now, in reality, before that web page hits, because we're using TCP, we would have a three-way handshake. So we'd have the SYN request going to the server, the SYNAC coming back, and then the acknowledgement for all that traffic, and it happens in milliseconds or less. It's amazing. Networks are amazing, and that's just for the three-way handshake. But this general flow of the traffic and how it works is exactly how it works. So that is sort of like the story of the kid who goes to his dad and says, "Dad, where did I come from?" And the dad says, "Okay, time for the talk." So he sits down, has books and manuals and diagrams, and spends 3 or 4 hours talking about the birds and the bees. And then at the very end, he says, "Do you have any questions, Jimmy?" And Jimmy says, "No." And Dad says, "Why do you ask?" He goes, "Well, Johnny next door said he came from the hospital." I am directly reminded of that joke because the question was static default route, static route versus the default route. And I went on and on to elaborate on a bunch of cool stuff that I thought was cool. And I hope it helps. The reinforcement will help too. Because in real networks, it doesn't matter if they're in the cloud or if they're on-prem or in your office or at your home. This is how the network works. And that's what I want you guys to know. All right, so that was from Raging Crypto. Thanks for that question. All right, and a lot of great answers from a lot of people. Thank you, thank you, thank you. Oh, thank you. Wilder is saying that link I gave you doesn't work if you do it within Discord, but if you do it from a browser, it'll get you there. So thank you for solving that for me. I appreciate that, Wilder. Thank you very much. And I think that's it. All right. Hey, I had a lot of fun. It's been Subnet Saturday, so the first hour of this was focused on variable length subnet masking. We identified 2 basic things. Number 1, if we take a pizza pie and we slice it up equally, we may not have enough room for all the hosts on a given subnet. We can optimize space that we have allocated to us by doing custom subnetting with variable length masks. And they refer to this as VLSM, variable length subnet masking. We walked through a couple examples of it, and also we tagged on one for the WAN connectivity with just 2 hosts as well as a little bonus point. I've thoroughly enjoyed having you for this live stream. It's been a lot of fun. Tomorrow, same bat time, same bat channel, 11 a.m. Pacific time, we're going to go ahead and cover another CCNA level topic, and I will be announcing that on social probably either this afternoon or early in the morning. Well, I say early in the morning, at least a couple hours before the live stream, so you can see what that topic is and see if there's any interest in grabbing it. So I see a few questions left in the queue. I'm going to go ahead and take a look at those with my fingers and texting, and I'll leave the stream running for a few minutes so I can do that. Otherwise, have a great rest of your day. I've got 110 people online right now. Thank you to everybody who's hanging out with me. It's great to get to know you, and I'll see you in the very next stream. Thanks, everybody.